Jyoti.
Present, sir.
Jyoti.
Present, sir.
Right. Kiran Ligade. Okay.
Yes,
Kiran
sir.
Ligade.
Yes, sir.
Okay. Right. Lakshmikant. Lakshmikant. Mantesh.
Yes, sir.
Mantesh. Right. Mole Prem. Mole Prem.
Present, sir.
Okay. Nagesh. Nagesh. Nandish.
Present, sir.
Right. Pooja.
Present, sir.
Okay. Pooja. Pooja.
Present, sir.
Right. Pramod
Present,
Kumar.
sir.
Okay. Pramod Kumar. Pramod Kumar. Praveen Magdum. Praveen. Priyanka. Priyanka.
Present, sir.
Okay.
Present, sir.
Right. Sandhya. Sandhya. Santosh. Santosh. Pujari. Santosh Sonar. Santosh Sonar. Shahbaz. Shahbaz.
Present, sir.
Okay.
Present, sir.
Right. Shafia.
Present, sir.
Okay. Sridhar. Sridhar. Srushti.
Present, sir.
Right. Siddharth Varnekar. Siddharth Varnekar. Siddharth Patil. Siddharth Patil. Supriya.
Present, sir.
Okay. Vandana. Vandana. Vasant. Vasant. Vedadatta. Vedadatta. Yogesh. Yogesh. Mahesh. Mahesh. Balesh. Balesh. Taik Mohammed. Taik Mohammed. Praveen Rathod. Praveen Rathod. Abhishek.
Present, sir.
Right. Aishwarya. Aishwarya. Amanullah. Amanullah. Bandodkar Tanay Mohandas. Bandodkar Tanay Mohandas. Bhavarav. Bhavarav. Shodhan. Shodhan. Devanar Anil Kumar Shekappa. Devanar Anil Kumar
Present,
Shekappa.
sir.
Right. Nand Kumar.
Present.
Okay. Nand Kumar. Nand Kumar. Pramod Kesti. Pramod. Rohini Pawale. Rohini Pawale.
Present, sir.
Right.
Present, sir.
Rohit. Okay. Rohit Alwani. Rohit Alwani. Shashidhar.
Yes, sir.
Right. Sridhar.
Present, sir.
Okay. Snehal. Snehal. Vaishnavi.
Present,
Vaishnavi.
sir.
Okay. Saish.
Present,
Saish.
sir.
Right.
Present, sir.
Okay. Kartikyam. Kartikyam. Smita. Kiran K. Kiran K. Right. Anybody else joined?
Sir, Shodhan.
Okay. Sure. Then anybody else? Right. In the last class, I was discussing few programs. Let us continue with some more programs in the today's class also. Are you able to see the screen, students?
Yes, sir.
Right. The program is like this. Write a 8051C program to toggle all the bits of P0 and P2 continuously with a 250 millisecond delay. In the last class, we have discussed a program to toggle the bits of P1 port continuously with 250 millisecond delay. Here they are asking to toggle two ports at a time, that is port P0 and P2. Almost it's the same program, right? Just we have to make use of two ports instead of only one port. That is the only difference. Let us write it. Hash include reg51.h header file. Next is the delay function void ms delay ms delay ms delay of unsigned integer. We are passing integer value, unsigned integer value, positive value to the function. Therefore, we have to make use of, we have to declare it as unsigned integer within the brackets. Then the main function void main function. We are not passing any value, therefore we are defining it as void. Then pass the value here p naught equal to, for toggling the value we are using two values, one is 55 and AA. 55 will be toggled to AA or AA will be toggled to 55. Those are the two values for toggling. P naught is equal to, if we are sending hexadecimal values, it is 0, 0x55, 0x55. Then P1 also we have to send the value because P0 and P2 also we have to send the value. P2 is equal to 0x 0x55 0x55. Then call the delay function because they have asked to introduce a delay in between toggling of the bits. Now call the delay function ms delay ms delay ms delay of how much delay they are asking to introduce 250 millisecond delay. A delay of 250 milliseconds, that means we have to pass the value 250. I discussed about this in the last class. We'll repeat it again. We are passing the value 250 to the delay function. Then p naught, I'll come to that. P naught is equal to, next toggled value is 0xAA 0xAA. P naught is toggled to 0xAA. Then P2 also we should toggle. P2 is equal to 0xAA 0xAA. Okay, P2 is equal to 0xAA. Now we have toggled it. Again call the delay function ms delay of 250 of 250. Right. Now end the main function. End the main function here. Then once we are ending the main while loop, while we have missed here, it has to be repeated. So after the main function, we have to introduce a while loop here. while of 1 or for of semicolon semicolon, anyone you can make use of, while of 1 or for of semicolon semicolon. First end the while loop, then end the main function. The main function we have to introduce a open bracket and while loop open bracket. First end the while loop, close it, then end the main function, then end the main function. Next comes the delay function. Whatever delay function we have written, that we have to define. Void ms delay of unsigned int, because we are passing 250 value 250 from the main function to the function. 250 is the value that we are passing. It is an unsigned integer. Therefore, unsigned int, to define the variable here I time, unsigned int I time. That means this value 250, whatever you are passing from the main function to the function, that will be stored in the variable I time. I time will become equal to 250. Then define the delay function. For delay function definition, we are making use of two for loops. For I is equal to 0, first for loop will be for I is equal to 0, I less than I time, I less than I time, I less than I time, I plus plus, I plus plus. This is the first for loop. The second for loop, we are making use of the value for j equal to 0. We have to define I and j. We will define that. For j is equal to 0, j less than 1275. This is the value. Remember this. J less than 1275. This I discussed in the previous class. J plus plus. J plus plus. Define the variables, that is loop indexes I and j. So it is unsigned integer I comma j, unsigned integer I comma j. Loop variables we have defined, loop indexes I and j, unsigned integer type, because they are positive values. I time value is 250. It will be repeated for 250 times. Inside for loop will be repeated for 1275 times. J loop for j equal to 0, j less than 1275, j plus plus. When it is repeated for 1275 times, it is going to generate a delay of 1 millisecond. When this particular program, this PC is being connected to a cathode ray oscilloscope, it has been tested that when this for loop for j equal to 0, j less than 1275, j plus plus is executed, it is generating a delay of 1 millisecond. It generates a delay of 1 millisecond. It has been verified on the cathode ray oscilloscope, Therefore, when this is 1 millisecond, this is repeated for how many times? I less than I time, 250 times. So it is 250 into 1 millisecond. That will be 250 millisecond. That means the delay generated from these two for loop is 250 millisecond. 250 millisecond, then end the function. Then end the function. Now this is the delay function. This is how first we are sending the value 55 to P0 using the while loop, then 55 to P2, right? Then we are calling the delay function, and this delay function is called 250 value will be passed from the main function to the sub function. It will pass from the main function to the sub function. Unsigned int I time, that is 250 will be stored in I time. Unsigned int I comma j, for I is equal to 0, I less than I time. That means this I loop will execute for 250 times, I less than I 250, I plus plus. Then inside for loop for j equal to 0, j less than 1275, it is executing for 1275 times. That many times multiplied by the outer for loop, that is 250. When it executes for 1275 times, it is generating a delay of 1 millisecond. Therefore, this is repeated for how many times? For 250 times, because outside loop is I less than 250. I time value is 250. Therefore, the for loop gets executed for 1275 into 250 times. that is 1 millisecond into 250. That will generate a delay of total 250 milliseconds. Now, once it is generated a delay of 250 milliseconds, it will return back. Then next is P naught is equal to 0xAA. It will return to the next instruction after the calling instruction. P naught is equal to 0xAA. AA will be stored in P naught and P2. The ports P naught and P2 have toggled. 55 is 01010101. AA is 10101010. That means 55 and AA are nothing but they are the toggled values. First, you can store AA and then toggle it to 55, or you can store 55 and then toggle it to AA. Anyways, then this is the for loop to generate a delay of 250 milliseconds. Again, it will call the delay function 250. It will pass the value. The delay function will execute and it will generate a delay of 250 milliseconds. After generating a delay of 250 milliseconds, the program will stop. Clear here? This is the program to toggle all the bits of P0 and P2 continuously with the 250 millisecond delay. In between, there is a delay of 250 millisecond. Clear with this program, students? Here P0 and P2, first we are sending 55, we are introducing a delay of 250 millisecond, then we are sending the value AA, or we are storing the value AA in P0 and P2 to toggle it. Again we are introducing a delay of 250. After delay of 250, again the P0 will be storing, P0 and P2 will store 55. Then there will be a delay of 250 millisecond. After delay of 250 millisecond, P0 and P2 they store the value of AA. This will repeat, right? This will repeat because there is a while loop here at the beginning. So this goes on repeating for indefinite number of times, while of 1. Okay. This is the program. Understood this program here, students? Is this program understood? Yes. Understood this program?
Sir, we are giving delay 2 times, no, sir?
This first delay is for the this in between delay, right? In between toggling of 55 and AA, we are giving a delay of 250. Okay. Then after AA, after we are toggling it from 55 to A, again in between AA to 55, again we are giving a delay of 250. Got the point here? This 250, it is for when
Yes, sir.
you are storing the value 55 in P0 and P2. After storing the value P0 and P2 55, we are giving a delay of 250. We are giving a delay of 50. After 250 milliseconds, P0 and P2 will store A. Then after 250 milliseconds, after A is stored in P0 and P2, 55 will be stored in P0 and P2. That is how it will go on repeating. Clear here?
Understood. Yes, sir.
Okay. Let us take up the next program. Note down this program statement. LEDs are connected to bits P1 and P2. Write an 8051C program that shows the count from 0 to FFH, that is 0000, 00002, 1111, 1111 in binary on the LEDs. Note down this program statement. Is it noted down, students? Did you all note down here?
Yes, sir.
Okay. Read the statement. LEDs are connected to bits P1 and P2. That means there are two ports, port 1 and port 2. We know that each port is of 8 bits. There are 4 ports, port P0, P1, P2 and P3. Now here we are making use of port 1 and port 2, P1 and P2. All the 8 pins of the port 1 they are connected to LEDs, and all the 8 pins of P2 also they are connected to LEDs. Right? What they are mentioning is write an 8051C program that shows the count from 00 to FFH. That means on the LEDs, it should glow whenever we are sending a high value or whenever we are incrementing the count here. That should be indicated on the LEDs. Right? For example, first we are storing 0. 0 will be sent on port 1 and port 2. Then it will increment. It's a counter. Next it will show 0, 1. So 0, 0, 0, 0, 0, 0, 0, 1. That will be displayed on both P1 and P2. Then next will be 0, 0, 0, 0, 0, 0, 1, 0. That is 0, 2. That will be displayed on port 1 and port 2. This will continue up till all the bits are high. It is from all the bits are 0 to all the bits are high. Okay, so all the bits are high means 1 1 1 1 1 1 1 1. That is FFH. This has to be continued. For this we have to write a program. That means the LED should glow based on the count value. Based on the count value, whatever we are sending to the ports P1 and P2, based on that the LED should glow. Now what all programs we are discussing in today's class, they are based on the IO port programming. That comes under the topic of IO port programming. That is, we are configuring the IO ports, and based on the configuration of the IO ports, we are writing a 8051C program. Let us write a program for this. Note down the ports, it is P1 and P2. Again, start with the header file, hash include reg51.h, reg51.h, reg51.h. Then what is the next statement? Next is we have to define one of the ports here. We can define it or we can leave it. If we want to define, we have to define it in this way. Define LED, that is P2. That means wherever there is port P2, instead of making use of port P2, directly we can make use of LED in the program. Right? That is, we are defining as P2 to be used as LED in our program. Next, main function, void main function. Then in the main function, first we have to send the values. We have already defined P2, and directly we can make use of port 1 because the declarations of these ports, they are already included in the header file reg51.h. Again, we did not define the port P1 is equal to 0 0. First value is 0 0. Then they are asking to send the values, count value on both P1 and P2. Then instead of P2, we can make use of P2 equal to 0 0, or we can make use of LED. But here we have defined it as P2 as LED. Therefore, I am making it as LED equal to 0 0 or LED equal to 0. LED equal to 0. Right? Then you can make use of for loop, or you can make use of the while loop, anyone whatever you wish. For semicolon, for semicolon, then flower bracket. In C language, in conventional C language that you have studied in your first year, how do you write the increment? P1 is equal to P1 plus 1, right? Or instead of that, we can write it as P1 plus plus, P1 plus plus. This indicates that, I'll write it in the form of a comment. P1 is equal to P1 plus 1, P1 plus 1. This is the meaning of P1 plus plus. P1 plus plus means P1 is equal to P1 plus 1. Similarly, we have to increment the count on LED also, port 2 also. LED means it is port 2 because that is how we have defined here. P2 equal to 0, 0 or LED equal to 0, 0. We have to increment the port 2 also, that is LED plus 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 plus. This indicates that LED is equal to comment line LED is equal to LED plus 1, LED plus 1. That is the meaning of LED plus plus. Then end the for loop, end the for loop first, then end the main function, close the main function. This is the program to send the values. How it will send the values? See, P1 equal to 0, 0, LED equal to 0, 0, P2 equal, this is P1 equal to 0, 0 is clear. LED equal to 0, 0 means it is nothing but P2 equal to 0, 0, P2 equal to 0, 0. Then we are making use of a for loop which will repeat for indefinite number of times. P1 equal to P1 plus 1. What will be the first value? First value we have initialized as 0, 0. Therefore, it will be 0 plus 1. 0 plus 1, that will be 1. That will be 1. Next time LED equal to LED plus 1. LED we have initialized as 0, 0 or P2 is 0, 0. That is 0 plus 1. That will be 1. That means P1 will be equal to 1. Okay. P1 equal to P1 plus 1. Again the for loop will repeat. P1 is equal to P1 plus 1. What is there in P1? 1. 1 plus 1. 1 plus 1. That is 2. Next time 2 plus 1. That will be 3. Next time 3 plus 1. That will be 4. So this goes on repeating for every next number of times. Similarly here also it is 1 plus 1, that is 2. LED will be 2. LED equal to LED plus 1. LED equal to 2. So LED will be 2 plus 1. 2 plus 1, that will be 3. Then next 3 plus 1, that is 4. That means it goes on repeating the count from 0, 0 up till FFH. From 0, 0 up till FFH. Right? This is how we are sending the count value on port P1 and P2. And depending upon the count value, the particular LED will glow or it will be off state. Either it will be in on state or it will be in off state. If it is 1, then it will be in high state. If it is 0, then it will be in the off state. If all are 1, then all the LEDs will be high. If all are 0 bits, all the 8 bits are 0, then all the LEDs will be in off state. Like this, the particular LEDs will glow. Is this program understood here, students? How to write this program? Any doubts here? Any questions here? Any questions? Was it understood, this program? Yes?
Sir, the program will means for loop is indefinite, sir.
Yes.
So the program will not end after it reaches FFH, sir.
No, you have to come out of the program. You have to do it manually. If you want to come out of the program, you have to stop it manually. Otherwise, the program will repeat for indefinite number of times. See, why it will repeat from 00 to 255. Again, it will go back and again it will repeat for 00 to 255. Then 00 to this will go on repeating.
Okay. Sir, if we use conditional statement in the for loop, it will stop.
Yes, definitely you can make use of. Definitely you can make. If you are using conditional statement in the for loop also, but for loop is outside, no? For loop is outside, is it not? Therefore, it will repeat for an indefinite number of times. Even if you are using the conditional
break statement,
yes.
Sir.
Huh?
Conditional statement with break.
Conditional statement with the break also if you are using, because if you are using for loop outside, even if you are breaking that, again it will come to for loop outside for loop, again it will continue. If you are using for loop inside and outside, if you are using conditional statement, then it will stop. Following the point, if you are making use of conditional statement here outside the for loop, if you are making use of some conditional statement, and inside if you are making use of for loop, then it will stop according to what instruction you are using, right? Otherwise it will not stop. Getting the point here?
Yes, sir.
Is it am I reachable to you? I understood my point here.
Yes, sir. Understood, sir.
Okay. We'll continue the next program, one more program. this statement, write an 8051C program to get a byte of data from P1, wait half second and then send it to P2. Write an 8051C program to get a byte of data from P1, wait for half seconds and then send the value to P2. Is it taken, students? Okay. Write an 8051C program to get a byte of data from P1, wait half second and then send it to P2. Let us write a program for this. As usual, start with the header file. First, understand the statement here. What they are asking, write 8051C program to get a byte of data from P1. That means you have connect. You are writing the C program for what you are writing the C program to get the value, to get the byte of data from port P1 of the microcontroller. Right? That means you are inputting the data from port P1. In respect to the microcontroller, whatever port is connected to your PC, you're inputting the data with reference to the port P1 of the microcontroller, you're inputting the data. Therefore, this port P1 has to be defined as input port. This should be very much clear here. See, what I am telling is, whatever the port of the PC you are connecting to the computer, whatever the port of the computer or the PC you are connecting it to the microcontroller, right? To the microcontroller, that microcontroller port is P1. That means you are inputting the value from port P1 into the your port of the PC, into the port of the PC or into the PC, right? That means the port P1 should be defined as input port. That is in reference to the port of the PC. This will become the input. In reference to that, just we should be very much clear about the word here. In reference to the port P1 of the microcontroller, the port of the PC that will be acting like an input port. Therefore, this port P1 should be defined as input port. Get the data from or read the data from the port P1 of the microcontroller. After reading the data, wait for half seconds. Wait for half seconds and then send the whatever value you have read from the port P1 to the port P2 of the microcontroller. First read the value from the port P1, wait for half second and then send that value to port P2 of the microcontroller. So this is how we have to understand this statement of the program. Now once we have understood the statement of the program here, I hope the statement is clear here. Program statement is understood to everyone? Yes? Okay. Then we'll write a program here. Hash include reg51.h reg51.h header file. Then comes the delay function, because it is very much clear that they are asking to wait for half second. That means it is a delay. Whatever the wait statement they are wait they have mentioned in the program statement, that is nothing but the delay. We have to give a delay of half second or introduce a delay of half second. Void ms delay of unsigned int void main function, void main. Okay. Then define the port P1. Define the port P1. For defining the port P1, I'm making use of unsigned character. Unsigned character, it will be sufficient here because the value that we are passing here to the my byte, it is of in character type. Okay. Or it is better to make use of integer data type here. Integer data type, because the value is high here. Let us make it integer data type. Integer, unsigned integer, my byte, my byte, my byte. Then P1, P1 is equal to P1 is equal to. I told while explaining the assembly language program that if we want to make use of any port as input port, what we have to store in that port first? How we have to configure that port?
0FF.
0FF, correct. We have to store FF in that port first. So store 0xFF, 0xFF into that port so that we can make use of that port as the input port. Make P1 as input port, as input port. Then call the delay function ms delay of 500 of 500. Sorry, P1 is equal to 0xFF. Then we have to repeat for indefinite number of times. While of 1 after initialization we have to repeat it, or for of semicolon semicolon. Then my byte is equal to P1. My byte is equal to P1. First, what we defined, unsigned integer my byte. P1 is 0xFF, that is we are making P1 as input port. After we are making port P1 as input port, then what I'm doing, I'm sending the value whatever is read on port P1 to my byte. Okay, whatever the value is read from port P1, I'm sending it to my byte. Then after what they are saying, after reading the value from port P1, wait for half seconds. How many millisecond equal to 1 second? How many milliseconds equal to 1 second?
1000 milliseconds.
1000 milliseconds, exactly. So how we are getting that 1000? Just here, 1000 into milliseconds. So it is 10 raised to minus 3. 1000 into 10 raised to minus 3. Ten raised to minus 3. Okay, so 1000 is 10 raised to 3 into 10 raised to minus 3. It will be 0. 10 raised to 0. 10 raised to 0 is 1. So this will be equal to 1 second. This will be 1 second. So when it is half second means 500 millisecond. Half second means 500 millisecond. 1000 millisecond means 1000 into 10 raised to minus 3. Raised 10 raised to 3 into 10 raised to minus 3. Index will be 3 minus 3 0. 10 raised to 0 is 1. This is 1 second. This is 1 second. They have asked to wait for half second. Half second means half of 1000 millisecond. That is 500 millisecond. Now after waiting for 500 millisecond, what we have to do? We have to send this value from my byte, whatever we are reading from port P1 to port P2. That is P2 is equal to my byte. P2 is equal to my byte. First we are reading from port P1 into my byte, then whatever value we are reading, we are sending it to port P2 after a delay of 500 millisecond or after a delay of half seconds. Then end the while loop, then end the main function, Next is simple, we have to write the delay function. Delay function is remain same for almost all the programs. Void ems delay of unsigned integer I time, of unsigned integer, unsigned integer I time, unsigned integer I time, then unsigned we have to define the loop index, unsigned, unsigned integer, integer I comma j, I comma j, for loop for I equal to 0, I equal to 0, I less than I time, I less than I time, I plus plus, I plus plus. This is one for loop. Outside for loop, we are passing a value of 500 to I time. I time value will be equal to 500. Variable, it is a variable. Next for loop, for j is equal to 0. This is fixed. J is equal to 0. J less than 1275. J less than 1275. J plus plus. J plus plus. End of the delay function. End of the delay function. This is how we have to write the particular program. That is, we are reading the value from port P1. Port P1, we are making port P1 first input port, configuring that as input port. We are reading the value from port P1 into some variable. Then the value, whatever is stored in that variable, we are assigning it to port P2. We are sending it to port P2 with the delay of 500 millisecond in between reading of the value from port P1 and sending it to port P2, or a delay of half seconds. Is this program clear here, students? This program is clear here? Any doubts in this program? Any doubts here, students? Akshata, any doubt? Bhakti, any doubt here in this program? Bhakti? Bharti? Bharti, Hadimani? Jyoti? Jyoti? Kiran Ligade? Kiran?
Sir, ಏನಿಲ್ಲ.
Mantesh? ಅರ್ಥ ಆತೇನಪ್ಪ ಕಿರಣ್?
ಹಾ ಸರ್.
ಓಕೆ. Mantesh?
ಹಾ ಸರ್ ಅರ್ಥ ಆಯ್ತು.
Understood, Mantesh? Any doubts?
No sir, no doubts.
Okay. Mole Prem?
Understood sir.
Understood. Okay. Nandish?
Yes, sir.
Clear, Nandish?
Understood.
Okay.
Yes, sir.
Okay. Pooja? 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 Okay. Praveen Magdu? Okay, fine. Priyanka?
Understood, sir.
Any questions, Priyanka?
No, sir.
Okay. Shabaz? Shabaz?
Sir, understood, sir.
Shafia?
Understood, sir.
Okay. Srushti? Srushti?
Understood, sir.
Right. Supriya? Supriya? Abhishek? Abhishek? Palekar? Shodhan? Shodhan? Devanar Anil Kumar Shekappa? Devanar Anil Kumar Shekappa?
while one ಅದೇನ್ ಸರ್
ಅರ್ಥ ಆಗ್ಲಿಲ್ರಿ? ವೈಲ್ ಆಫ್ ಒನ್ ಅಂತಂದ್ರಿ ದಿಸ್ ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ಏನೈತಲ್ರಿ ಇದನ್ನ ಏನ್ ಮಾಡ್ತೈತೆ ಅಂತಂದ್ರಿ ವಾಟ್ ಎವರ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ಯು ಆರ್ ರೈಟಿಂಗ್ ಇನ್ಸೈಡ್ ದ ವೈಲ್ ಲೂಪ್ ದಟ್ ವಿಲ್ ಬಿ ಎಕ್ಸಿಕ್ಯೂಟೆಡ್ ಫಾರ್ ಇನ್ಫನೈಟ್ ನಂಬರ್ ಆಫ್ ಟೈಮ್ಸ್. ಅದ್ ಎಂಡ ಆಗಂಗಿಲ್ರಿ, ಅದು ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ರಿಪೀಟ್ ಹಾಕೊಂತಾನೆ ಇರ್ತೈತ್ರಿ. While of one means whatever statements are written inside the while loop, while of one means condition is always true. condition will never become false. The meaning of while of 1 is condition is always true. Therefore, it is in infinite loop. It is in infinite loop. It will repeat for indefinite number of times or infinite number of times. Whatever instructions we are writing inside the while loop or inside for of semicolon semicolon loop, those instructions will be executed infinite number of times. Only you have to do it manually. You have to come out of the program. Okay, manually you have to come out of the program. Only then it will stop. Otherwise, it will be continuously repeating. Whatever function you want to perform, whatever logic you want to perform, that will go on repeating. It will never end until unless manually you come out of the program. ಅರ್ಥ ಆತ್ರಿ ದೇವಣ್ಣವ್ರ ಅರ್ಥ ಆತಲ್ರಿ ಓಕೆ ಓಕೆ
ಹಾ ಸರ್ ಹಾ ಅರ್ಥ ಸರ್
ಫೈನ್ ರೋಹಿಣಿ ರೋಹಿಣಿ ಪಾವಳೆ ಶಶಿಧರ್ ಶಶಿಧರ್ ಗೌಡರ್ ವೈಷ್ಣವಿ ಶ್ರೀಧರ್ ಬಡಿಗೇರ್ ಶ್ರೀಧರ್
ಸರ್ ಅಂಡರ್ಸ್ಟುಡ್ ಸರ್ ಎಸ್ ಸರ್
ಓಕೆ ಫೈನ್ ವೈಷ್ಣವಿ ಸಾಯಿಶ್ ಸಾಯಿಶ್ okay in the next class we'll take up few more programs on the IO port programming and then we'll continue with the subsequent topic in this module. Okay, any questions here students, anything you want to ask? Thank you, we'll continue in the next class.